In recent weeks, a fundamental revolution has been taking place at Tesla's factories in Fremont and at Gigafactory, Texas, one that analysts are already calling the most significant shift in industrial manufacturing since the emergence of Henry Ford's assembly line. According to insiders, Tesla has begun the mass deployment of third-generation Optimus humanoid robots directly on the production lines where CyberCamp vehicles, specialized robotaxis, that are expected to form the foundation of the future autonomous transportation fleet, are being assembled. These are no longer laboratory demonstrations or isolated prototypes. This is a working reality in which robots, under the supervision of engineers, are performing increasingly complex operations, sorting and installing components, moving heavy modules, participating in surface preparation for painting, carrying out final polishing, testing assemblies, and transporting finished components around the factory. Humans still control the critical stages, but the trajectory is obvious. Tesla is preparing for robots to take over automobile assembly almost entirely in the coming years. According to Tesla's second quarter 2026 report, published on July 22nd, the company officially dismantled the Model S and Model X production lines at the Fremont factory. The process took just 46 days, a record pace for a conversion of this scale. The freed-up space is already being equipped with the first modular lines for the mass production of Optimus. Elon Musk personally walked through the line on July 1st and published a photograph with the team, emphasizing that the initial stage would be extremely slow because almost everything about Optimus is new, around 10,000 unique components, an entirely new supply chain, and new processes. Nevertheless, internal sources cited by the Wall Street Journal and specialized industry publications claim that pilot production has already begun or will begin in the coming weeks. The goal of the first Fremont line is to reach a production capacity of approximately 1 million robots per year. At the same time, construction of a much larger facility is proceeding at full speed on the northern side of Gigafactory, Texas, with a long-term target of 10 million units annually. Construction is progressing at a pace comparable to, or even faster than, the construction of Gigafactory, Texas itself several years ago. In practice, Optimus is already working side by side with humans. According to employees who anonymously shared information with analysts at Nomura and UBS, the robots are sorting 4,680 battery cells, moving components between stations, and performing visual quality inspections using a camera system inherited from full self-driving. More advanced units are participating in light assembly, installing fasteners, and preparing surfaces. On the CyberCamp line, which uses a fundamentally new unboxed manufacturing process, the parallel assembly of large modules instead of a conventional linear assembly line, robots help connect the front and rear sections, side structures, the battery, and the interior. They move heavy components that previously required several people or stationary robotic manipulators. In the areas dedicated to paint preparation and final finishing, Optimus robots are already being tested on tasks involving polishing and inspection of paintwork. For now, all of this is taking place under the close supervision of engineers and operators. Every robot is operating in a human-in-the-loop mode. Individual CyberCamp vehicles are being assembled with the assistance of robots, but a complete production cycle without human intervention has not yet been achieved. Nevertheless, insiders from the manufacturing teams say that the pace of training and data accumulation is enormous. Every hour of Optimus operation generates terabytes of information, which is immediately fed back into the training of neural networks. Tesla plans to deploy hundreds of thousands of these robots in the coming years. The company's official targets and Musk's statements during investor conferences indicate that Optimus production volumes are expected to increase by an order of magnitude by 2027. Initially, the robots will be used primarily within Tesla itself, at factories in California and Texas, and eventually in Shanghai and Berlin as well. After that, external deliveries will begin. Musk has repeatedly said that Optimus could become the biggest product in history, surpassing even Tesla vehicles themselves in terms of impact. The logic is simple. If a robot can reliably perform work in a factory, it will be able to assemble not only CyberCamp, but any other vehicles as well. And not just assemble them, it could build the factories themselves, install equipment, and maintain production lines. Internal documents cited by industry analysts describe a scenario in which, within several years, a significant portion of Tesla's manufacturing could be carried out by robots with minimal human involvement. First under supervision, and later almost autonomously. Millions of vehicles per year, assembled by machines that were themselves assembled by machines. What does this mean for Tesla workers and for employees at other companies? Inside the company, the tone remains cautious but optimistic at the same time. Musk has publicly stated that Tesla does not plan mass layoffs because of Optimus, and even expects its workforce to grow, because new roles will emerge: robot operators, maintenance engineers, data specialists, and supervisors responsible for managing entire fleets of Optimus robots. Many employees are already undergoing retraining. However, the reality on the factory floor is more complicated. Workers who have spent years performing monotonous tasks, such as installing components, moving parts, or carrying out final inspections, are watching those jobs gradually shift to robots. In union circles and private employee chats, the discussion is less about the fear of immediate dismissal and more about the feeling that the familiar world of factory work is coming to an end. Similar sentiments are already being recorded at competing manufacturers. In South Korea, Hyundai facilities have seen strikes linked specifically to plans to introduce humanoid robots. In Europe and the United States, automotive unions are closely watching what is happening at Tesla, understanding that if one manufacturer manages to dramatically reduce the share of manual labor, the others will be forced either to catch up or lose competitiveness. At the level of the broader economy, the consequences could be far deeper. The automotive industry is only the first wave. If Optimus truly learns to reliably assemble complex products, paint, polish, test, and transport components, the technology will inevitably move beyond Tesla. Logistics, warehouses, construction, electronics, and even agriculture. Anywhere there is repetitive physical labor, humanoid robots will emerge. Analysts are already comparing the current moment with the arrival of industrial robots in the 1960s and 1970s, but with one crucial difference. Those robots were specialized and tied to a specific task. Optimus is designed to be universal. It can be retrained. Today, it assembles batteries. Tomorrow, it helps on a painting line. And the day after tomorrow, it works in a warehouse or another factory area. This changes the economics of labor itself. Productivity could increase dramatically. The cost of manufacturing complex products could fall sharply. But at the same time, a fundamental question arises. What will happen to the tens of millions of people whose jobs consist precisely of performing such operations? In Washington, Brussels, and Beijing, policymakers are already beginning to discuss possible responses. Some argue for large-scale retraining and reskilling programs. Others advocate for a basic income that could compensate for the reduction in traditional jobs. Still others warn that countries and companies that are late to adopt these technologies risk ending up in the same position as those that once fell behind during electrification or the digital transformation. Tesla, with its enormous head start in artificial intelligence, real-world data, and vertically integrated manufacturing, is currently in a unique position. The company is not simply buying robots, it is creating the robots, the vehicles those robots will assemble, and the infrastructure in which they will operate. This is a closed loop that could potentially provide a massive competitive advantage. For now, however, all of this remains at an early stage. The robots on the CyberCamp production lines are operating under human supervision. Fully autonomous assembly of entire vehicles is still ahead, but the direction of travel can no longer be ignored. In the coming years, Tesla intends to deploy hundreds of thousands of Optimus robots on its production lines, then millions. And when that happens, the question will no longer be whether robots can build cars. The question will be how society adapts to a world in which physical labor, in the traditional sense, ceases to be a mass necessity. Tesla insiders say that inside the company, this moment is already being perceived not as a distant future, but as an imminent prospect. And if we believe those who see these processes from the inside, as well as reports from respected publications and financial research firms, we really are standing on the threshold of one of the deepest transformations in the history of industrial manufacturing. The most unsettling and at the same time fascinating part is that this transformation is already irreversible. While politicians and economists are only beginning to formulate their responses, the robots at Tesla's factories continue to learn. Every day they become slightly more precise, slightly faster, and slightly more autonomous. And when the first millions of vehicles roll off production lines in a few years, assembled with almost no human involvement, the world will look back and realize this was when it truly began in these August days of 2026.